Hello, in this case, what we are going to do is to get the free body diagram of the simple machine. And we will use an assembly mode, of course, to do this. And in this case, what we have a kind of an arbor press, where you apply at the end of that 400 millimeters arm, you apply the force. In this case, the force is 250 Newton. And the force is transferred through the link to the die. And the question is, if we have this geometry as specified in this model, what is going to be vertical force on the die exercised by applying a 250 newtons on the handle? So we are first going to make all of the parts, and we will start by making the part which is the arm itself. And we will extrude that arm, and then we are going to create the mating points, because this will be again simplified machine. So we are going to start by making a sketch in the front plane, going to make a horizontal axis, then I'm going to make another axis which will be from the origin up with the aligned length 200 millimeters and with the angles between the horizontal and the length of 60. Change my units to the mmgs and continue sketching. Now I'm going from that point to make another construction line with the angle of horizontal of 15 degrees and with the aligned length of 400 millimeters. This will define the basic geometry of my arm. Now I'm going to put the construction lines. I will start by placing circles, and then I will connect the circles with the tangent lines. Specify that this circle is the radius 12.5, so that's 25. I'm sorry?
Is that supposed to be shown on screen?
Okay, we do the one polar line, then we do second polar line. The first polar line is 60 degrees with the length of the 200, and the next polar line is the length of the 400 and angled 15 degrees of the horizontal. Now we are going to put the three circles at the three origin points. And this one is 37 times 5, 0.5 times 2. And this one here, the last one is 12.5, that means 25 diameter. Now, we will connect the circles with the tangential lines. And as you can see, as I hover close to the circle and attach to it and then go to the next one, it automatically inherits, if I hover in an area where there will be tangent, it automatically inherits the tangency relationships. Now, same thing from here. Need to zoom in a little bit. See, it's tangent and coincidental, and it's tangent and coincidental, and the same things will be and at the bottom we need to click on the circle and circle to make them tangent. And here I'm going again to click line and the circle. And actually this is already a okay. Now what we can do, we will have here some object of confusion, so some area of confusion. So if I go to a power trim, can actually successfully trim these lines, so I can clean out this sketch. As long as I just trim the circles, it should stay fully constrained. And now I see where is the problem, so I will erase this vertical relationship and I'm going to make this to be tangent, which fixed it. Okay, so here is my cleaned out sketch. Now I'm going to extrude this sketch for a 10 millimeters, and I'm going to create a new sketch on the top of it that will define the pivot point. So I will close this sketch, extrude the object for a 10 millimeters, and then I will start a new sketch, so on the top surface, and I'm going just to place 3 points, 1, 2, and 3. And now I'm going to make this point and the bottom circle to be concentric, this point and the middle circle to be concentric, and the last point and the circle to be concentric. And this defined my arm. Why I created this point? These points I will use to create a functional assembly by mating point to a point. Going to close the sketch, and I will save this as an I will call this one the arm dash press. Now I'm going to create the next part, and the next part will be my link. And the link is a very simple sketch. On the front plane I'm going to use the slot, the straight slot. And again I will need to change this to the millimeters units. The distance, the center distance of the slot is 180 millimeters, and the diameter of the slot is 25. And I'm going to extrude my link, and again 10 millimeters. I'm going to create now on the front plane, I'm going to create here 2 points, one concentric with the one end of the slot, second one will be concentric with another end of the slot, and I'm going to save it. One thing that will be easier to assemble later is to have to avoid doing the z-axis. Actually, we don't need to do that for now. Let's see it this way. We can do it. Okay, I will save this as a link. Save as a link dash press. And the last part will be a die. And then we are going to assemble those together. Part is also the die, is also a very simple part. Going to make a very simple centerpiece rectangle. going to create the length of that rectangle to be 30 millimeters with a height of 15 millimeters, and we'll have a arc starting from the middle point and we will say that the center and center are vertical. This fully defined this piece. And I'm going to make also another point here, so I'm going to extrude this piece for a 10 from a mid plane. Go to the extrude, 10 millimeters, and it will be a mid plane, and I will choose both options. Now we are going to create the bottom circular piece, and that will be again the sketch on the front plane, and this time I'm going to make a revolved piece by making a rectangle which will be 25 millimeters by 25, essentially a square, and then revolving it around this axis. So I close the sketch, feature, revolve both space, axis of revolution is the left angle, and here is my die. I'm also going on a front plane to start a new sketch, and I'm going to define a point which is going to be a center point of the die. And I'm going to save it. Now the key is to make the right mates in assembly. So let's start making assembly. Let's start making a new assembly. And we are going to insert all of the components. So we'll start by arm, and we just drop them inside. I will insert other component, die press, and I will insert another component, leg press. Now we need to make our arm to float, otherwise it will not make. So right click on the parametric tree for an arm, and let's make it to float. Now we will make everything as a, not as a completely correct geometric, but actually as a 2D model which will have the right kinetics. So to make that, we will make all of the front planes to be coincident. So I'm going to choose the front plane of the arm and press shift and my global front plane, so mate. I will choose the front plane of the arm and our global front plane, and I will make it coincident. Now I will repeat the same things for the front plane of the die, mate it with a global front plane, and finally I'm going to make the same thing with the front plane of the link and make it with a global front plane. After I made this, so I'm going to now start actually assembling functional kind of a sketch. So I'm going to create a mate point between the left point of the arm and the global origin. So I will choose the left pivot point of the arm and the global origin, and I'm going to make this too. So pivot point of the arm with the global origin, and it will be a coincident without aligning the axis. Now I'm going to create another coincidence between this point and the center point of the arm. And let's see, and then coincident with the other point of link and the point on the die. So I'll drop down the die, and I'm going to make a coincident of this point and that. Alright, so we have one thing that we need to correct here. If I go here for the arm, if I choose the global, okay, if I made it from the mid plane, then it will work properly. Okay, now this is in a reality a 2D model. So the kinematics looks right, however we need to constrain some other motion in order for this to be feasible model. So what else we don't have constrained? We need to put the between the right plane of the arm and the global right plane. This will fix the arm in its initial position. And so if we look at the right plane of the arm, right plane of the arm, I'm going to mate with the global right plane. And I'm going to undo that mate later. So this is just to set up the right geometry for start. And then top plane of the link and the global right plane. Yes, so the top plane of the link mate with the global right plane. Let's see if that's correct. Yes. Okay. And here is our initial position. That will be our initial position for an analysis, because otherwise that thing floats. So that's our initial position for the analysis. And now we are going to create, we are going to suppress those two mates. In the global right plane, we need to specify that the distance here is a 20 and that the angle is actually 20. So this one, going to edit that mate, it will be an angular and it will be a 20 degree. And we will need to click on a flip. Yeah.
On the second.
Yeah, flip dimension here. Okay, that's now our initial condition, correct. Later on we are going to suppress, and actually we can do this. If I click the last coincident and this one, and right click, I'm going to suppress. Going those mates, going first this one, suppress, another one, suppress. However, now I need to be careful not to move. Yes. And now phase one of the plane, and we need to do the phase one of the die, and the global origin, and we will click lock. So to keep this one now, mate, not the edge, it will be a face of the die, and the global origin, no, it will be a locked, and that will keep that actually die, that will keep the condition, that will keep the geometric constraint. Now we are ready to start doing the motion study. We first check that we have the add-ins installed. SolidWorks Motion, and this should be both okay. Now if I click on a tab for the motion study, here is my motion study. Let's check the force. I'm going first to put the force here looking downwards. I will click on a force, and this first I will choose the MMGS units. Going to check, click on the force at this point, action only, and then it will be in a normal to the global top plane and looking downwards, and the initial force is 250 newtons and is constant, so we place that force. Now, all what we have to do is to click calculate. We will choose the type to the motion analysis. And if we click calculate, first, what was the first good sign? Okay, guys, what was the first good sign? Didn't move. That means that it is a static case. Now, what is actually going to be the reaction force in my, what are the two actually constraints? What are the two that defines actually, that defines the, it will be the lock. For the lock mate will define actually fx and fy. So if I click on a results, forces, select the subcategory. Let's see what is the force in a y direction. That will be a reaction force, y direction. Select one mate simulation element. I'm going to choose the lock one, and that will be in a y. And let's check the values. No. So what is the value here?
747.
And that is exactly what we get in an analytical solution. Now, in that same fixed constraint, if we check for the x value, what will be the x value? Will be the 271 newtons. So let's do it. So again, I'm going to choose my result window. I'm going to choose force. I'm going to choose the reaction force. Going this time to choose the x component. Yep. And I'm going to choose the mate lock. And you can see x, y, z, and this will be the x. And we can, if you want, we can add it to an existing plot, plot 1. No. What is the other one? Negative 271. Okay, and now we can also explore the reaction force in any other pins. So explore the reaction force in the pin here and the reaction force there. So if we go here, reaction force, let's say the y component, and that will be just to find the right mate. How about this guy here? And that's exactly what it is. The reaction force is downwards 496 newtons. And so on. Now we can, yes, now we can draw the free body diagram by hand or by sketching it in a SolidWorks, and you will see that it is correct. So, what is this model showing us? How from that simple examples that we did before, like brackets, you know, and a simple arm, now actually we can use to analyze the forces and as well as torques acting on the mechanisms in a steady state. So, and that's actually one of the roles of statics. We can actually look into the loads on the mechanisms. Okay, now it's for you to complete this exercise.